Crude oil. So what is crude oil? Well, it's a mixture of a large number of compounds. Remember mixture again? Sorts of different types of molecules and atoms which can be separated. They're not chemically joined to each other. It's obtained by drilling through rock, so again it has a huge environmental impact. Most of the compounds in crude oil are hydrocarbons. Now these are molecules containing only hydrogen and carbon atoms. Now in the exam, if you miss out that crucial word only, you won't get the mark because there are lots of molecules that contain hydrogen and carbon atoms, but hydrocarbons contain nothing else. So you must say they contain only hydrogen and carbon atoms, and most of these are alkanes. So let's have a close look at hydrocarbons. So the majority of hydrocarbons in crude oil are alkanes. Now these are saturated hydrocarbons. Now they're called saturated, not because it's anything to do with being wet, but it's because they have only single bonds. They have no double bonds. And saturated is a chemistry term used to describe something that has only single bonds. Now again, in the exam, if you're asked the definition of saturated hydrocarbons, if you miss out that crucial word only, you won't get the mark, because there are lots of hydrocarbons that have single bonds and double bonds and even triple bonds, but alkanes have only single bonds, no double bonds. So you can see there that they have the general formula CnH2n plus 2. So N stands for a number. So in this molecule that we have in front of us, there are 2 carbons and there are 6 hydrogens. So Cn, C is 2, and H is 2 times 2 plus 2, H6. Properties of hydrocarbons. Now, different hydrocarbons have different chain lengths. So, for example, we can have C12H26, which is a much longer chain than C3H8. Now, the different lengths gives the molecules different masses. Different masses affects their boiling points and melting points because larger, heavier molecules will require more energy to break free and evaporate from a liquid. It will also affect their viscosity or stickiness. So a viscous substance is something that's thick and sticky. Now long chains tend to get more tangled, so they flow less freely. So the longer the chain is, the more viscous it tends to be. Now, as longer chains evaporate less easily, they tend to be less flammable. It's more difficult to set fire to them, to ignite them. And the reason for that is because it's the vapour that floats around on the surface of the fuel that actually ignites, not the liquid part of the fuel at all. So the more easily it evaporates, the easier it is to ignite, the more flammable it is. So let's have a look at those trends then of hydrocarbons. So as the chain length increases, so does the boiling point. So the boiling point will increase with the longest chains. The flammability decreases though, so the longer the chains, the more difficult it is to ignite. And viscosity increases with increasing chain length. The longer the chain, the thicker, the stickier, the more viscous the substance is. Now, it's very easy to get a bit confused about boiling points when we have negative signs in front of it. So just remember, if it's a negative number, the further it is away from 0, the colder it is. So large negative numbers are colder than small negative numbers. Just remember that. Fractional distillation of crude oil. This is how we separate crude oil into the different hydrocarbons. Now, it's a mixture of hydrocarbons, which means that these substances have different melting and boiling points. So we can separate them by distillation. Now this involves heating the oil to 350 degrees, allowing the compounds to evaporate. Anything that's still liquid will flow to the bottom of the fractionating column, but vapours rise up the column. Now, it's cooler at the top of the column, and the vapours cool as they rise. So when they cool, they'll reach their boiling point, which means they change from vapour to liquid, so they condense. So as the vapours condense, as they cool to their boiling point, they'll flow out through a pipe. So here we have a fractionating column, and in principle, because it's cooler at the top, hydrocarbons of lower boiling points condense here. So this means if it boils or condenses at a lower number, at a more negative number, it'll rise up the column and it'll condense here. The column is hotter at the bottom. So hydrocarbons of higher boiling points condense here. They go from vapour to liquid at a higher temperature. So cooler at the top, that'll be the gases that condense there, and hotter at the bottom, that'll be the thick sticky residues, the tar and the bitumen will condense at the bottom of the fractionating column. Now it's important to remember that each fraction itself is a mixture of hydrocarbons. So at each point where they're separated, where they flow out through the pipe, that's still a mixture of hydrocarbons, but it's within a narrower range.